Hey, AP Chemistry students, it's your favorite AP Chemistry teacher here. I just want to quickly go over a problem with you here involving the pH of a salt. Since we had to rush through this during class, I wanted to make sure that you could actually see how to solve this particular problem. So this was the one that we did not have time for. As you can see here, you're asked to calculate the pH of a 0.30 molar solution of sodium fluoride. All right, as you could tell, that is a salt. That's not an acid or a base. It's from the reaction, the neutralization reaction of an acid and a base. And they gave you the K value for HF. Okay, so to do this, the first thing you really need to do here is figure out where did that NAF come from. So if we think about this here, we have NAF and we're trying to figure out where it came from. The Na would be Na plus, and that obviously had to be coming from the base or the NaOH, and the F minus part of the NAF had to come from the HF, okay, hydrofluoric acid. So these were your two substances that reacted together to do your double replacement or your neutralization reaction, essentially, to give you the NAF plus water. So that's the neutralization reaction that took place in order to generate the sodium fluoride, the salt there. Remember, typically an acid plus a base generates a salt and water. So when we analyze this here, the acid and base that the NAF came from, the NaOH is a strong base, and the HF is a weak acid. So from this here, since it came from a strong base and a weak acid, we know that the NAF is going to hydrolyze with water to generate a pH that is more on the basic side. Because it came from a strong base and the acid was weaker, we're going to see a basic pH here. So we have to think about which part of the NAF now is going to react or hydrolyze with the water to generate a basic pH. Basically, which part? Is it the Na plus or the F minus that will react or hydrolyze with the water in order to get me OH minus, because it has to be basic. Okay, so that's what we're trying to figure out here. So the F minus is the one that would be able to react with the water. Okay, this reaction is an equilibrium reaction, and when the F minus hydrolyzed with the water, I would get HF plus OH minus. Remember, we said that the salt came from a strong base and a weak acid, so we have to generate a more basic pH, and by generating that OH minus, that's essentially what we're doing. Okay, so we're going to make our ice table here now. We know that water is a liquid, so it does not participate in our ice table. Our initial concentration of our fluorine ion here was 0.30 molar. The initial concentrations of the HF and the OH minus were 0. This is going to change by some value of x. These are going to gain some value of x. It's all 1 to 1 in the balanced equation. So at equilibrium, this is 0.30 minus x molar. This would be just x molar, and this would be just x molar. All right, so now when you're looking at this, very important to remember that you generated an OH minus. So we need a Kb here, but we were given a Ka. So we have to convert this. We know that Ka times Kb is equal to Kw, which is equal to 1 times 10 to the minus 14th. All right, so if we take, so to solve this, we know that Kb would be equal to 1 times 10 to the minus 14th all over the Ka that they gave us, 7.2 times 10 to the minus 4th. And when we do the math there, we get the Kb to be 1.4 times 10 to the negative 11th. Anytime you need to pause this video to do the math, to check in, see if you can do it, go ahead and pause away. So now that we have our Kb, we can write our Kb expression, which we know would be equal to products over reactants. So concentration of HF times the concentration of OH minus all over the concentration of F minus. Okay, so now we're ready to actually plug in and solve here. So now that we have our Kb expression, we know that Kb is 1.4 times 10 to the minus 11th. That would be equal to x squared because both of our products were x in the ICE table, all over the 0.30 minus x. Okay, that is your concentration of your F minus. We know that the x is negligible here, so when you solve this for x, you should get 2.0 times 10 to the minus 6 molar. And remember though, that's the concentration of OH minus according to our ICE table. So the problem wants us to find the pH, but remember here, this is the concentration of OH minus. So essentially, we know that POH is equal to the negative log of the concentration of OH minus. So we know that the POH is going to be equal to the negative log of 2.0 times 10 to the minus 6th, which is equal to 5.70. So pH plus POH equals 14. 14 minus 5.70, that's how you get the pH, the final pH, which is 8.30 here. Does this make sense according to what the salt told us? We said it came from a strong base and a weak acid, so the pH of the solution should be basic, and it is in fact above 7, so it has a basic pH. So that's how you go about solving this particular problem involving a salt. Remember, it's always important to go back and analyze the salt to figure out where it came from, and then do the appropriate hydrolysis reaction with water to generate the acid or base you need.